Hi, everyone. Welcome to the last presentation of the day. We're going to talk about interesting insights from now 8.5 and more thousand databases that are monitored by ProTop. So, one of the fun things about having ProTop deployed all over the world, monitoring now almost 10,000 databases, is I have all the data from all these 10,000 databases. And we're like, okay, cool. Let's look at all this data and let's see what interesting information we can pull out of the data and that we can share with all of you. And then you can kind of look at some of this and compare it to what you have and see if there's improvements you can make, or if you're in the middle, or if you're big or small or whatever. Come on. There we go. For those that don't know me, my name is Paul Koufalis. I'm the president of White Star Software. I have been an OpenEdge DBA for 30 years now. 30 years. Never been a programmer. Never. Well, I have written code, but I'm forbidden from writing code because it's not very good code. So I'm not a coder. I am a DBA, kind of sysadmin, techie, geeky type of guy. Always have been for that. Um, I'm going to show you some stuff about ProTop here. Disclaimer, it's a commercial software package. There is a free version you can download from protop.com. This isn't a commercial session. That was 2 hours ago that I did a commercial session. Some of you might have been there. But some of the stuff I'm going to show you from ProTop, at least, is part of a commercial package. All right? Don't get mad at me, please. And if you have any questions, you can email me or come see me at the booth afterwards. And also, if you have a question or a comment or anything, feel free. It's 5 o'clock on a Wednesday afternoon. We're going to have beer afterwards. I really don't care. Feel free to interrupt me. It'll just make it more interesting. All right? Please. So we'll just quickly go through who's White Star, what's ProTop quickly, and then I'll go through some of the statistics that I've pulled out of all of this data. We have these terabytes and terabytes of time series data that we have accumulated and pulled out some interesting metrics that I wanted to share with you guys. All right, so who's White Star? In a nutshell, we simplify the job of managing and monitoring the world's best OpenEdge applications, right? We are the purveyors of ProTop. We've all been in this business for 30 years or so. In fact, 30 years, I'm like number 4 or something in terms of the seniority list at White Star Software, right? The Tom, Adam, and Ug, those guys have been around since the late 1980s practically in terms of their OpenEdge experience, right? And that's really what we do. We don't develop any code. We don't manage anybody's OpenEdge environments or anything like that. Really, we just help people and we help them manage and monitor their environments. All right? Again, doing this for 30 years now. We have a global customer base, and really that's what makes this data the most interesting. Like, you're going to see this data comes from 10 user systems and 10,000 user systems, right? From 10 terabyte databases and 10 megabyte databases. So we see it all. Linux, Windows, AIX, HPUX. We're monitoring everywhere. Version 9, version 10, version 11, version 12. We have clients across all of these different combinations and variations and permutations. And again, that's where it gets really interesting. And also what's fun is our customer bases vary. So we have manufacturers, we have distributors, a lot of financial institutions, and each one of them use the Progress database differently. And you can see that difference in how the different vertical markets use the Progress database. Good. And what is ProTop? Like I said earlier, it's the only commercially available Progress specific or OpenEdge specific monitoring tool available. There's a lot of other tools that can monitor OpenEdge, but there's nothing like ProTop, right? A lot of people will take Zabbix and they'll add scripts into it, for example. OpenEdge management has some monitoring in it, but really it hasn't really advanced much, and now they're replacing it with OpenEdge Command Center, for example, right? And we monitor over 1,000 different metrics. So the data that I pulled out today is really from this gathering of 1,000 metrics. And we sample data every minute typically from your databases when we're monitoring them. So we have that near real time, 1 minute age data in our data portal at any given time. All right. And what isn't ProTop? ProTop doesn't do anything. It's not a management tool. So it's not meant to start or stop databases. Um, and it's not a managed database service like MDBA or some of the others who do really full-time consulting. We don't really do a lot of consulting. We come in, we'll help you with a small project, but mostly we want to come in, teach you how to do the small project, guide you through the small project, right? And then leave, right? We're really not in there to come in for a year and work full time for a year. That's not what we do. And we don't have the bandwidth to do that. We want to come in, teach you, like a lot of our customers, we have monthly calls with them. So every month we have a 1 hour call with them just to catch up. They can ask questions, show us something. Hey, I saw this. It was strange. What is this? And that's kind of all included in the package when you work with us, rather than it being hourly consulting or something like that. And who uses ProTop in Europe? End users, financial institutions, like I said. A lot of application partners are using ProTop in Europe and, of course, all over the world. And great. And then this slide keeps changing, but right now ProTop is deployed at around 1,100 end user customer sites around the world. Pushing 2 petabytes of data and pushing now 10,000 databases that we monitor with ProTop. So quite a bit of growth and really a lot of OpenEdge environments that are monitored by ProTop. So why do I tell you all of this? Because I want you to see that the data that I'm about to show you is really comes from a very wide source here. So the first and most interesting thing for me was, well, what version of Progress is everybody running? And you know what? The first thing that struck me here is you guys in Europe have always been far ahead of Canada and America in terms of upgrading to the latest version of Progress, but that's not true for 12. So PAS-OE scared you guys in Europe more than it scared the people in America, because if I look at our customer base, we got about half in 11 and about half on 12, whereas if I look at our European customer base, 80% are still on 11. So I'm going to ask in this room, who's on 12? In prod, eh? 1, 2, 3. And who's on 11? So it's 50-50 in the room here. Okay. Plus the liars who are in 12 in dev and they put their hand up anyway. So, yeah, I was surprised to see that. But mind you, this number is changing every day, right? I mean, I got to say, all of our version 11 customers are somewhere on the path of migrating to 12. You've got that drop dead date next spring, right, when 11.7 retires, and everyone's kind of scared of that date. So all the people who have been putting it off and putting it off and putting it off, well, now they're like, oh, we can't really put this off any longer. We should probably upgrade. And you're like, oh, by the way, Classic App Server, you've got to do something about that. It doesn't auto-magically run as PAS-OE. There's sometimes a little... Who's done the classic to PAS changes here? How easy? A scale of 1 to 10.
Easy at first.
So not done.
Exactly. It looks easy at first. Look, I just ran the code. It worked. All right. Yeah, so this really surprised me that that you guys here in Europe were, at least I took this data a little earlier in the springtime, and you were still 80% OpenEdge 11. So that was pretty cool. But again, I expect by this time next year, it's going to be like 80% 12 across the board, right? So what else is interesting? Hypervisors. So 2% of our clients are on AWS. 8% of our clients are running on bare metal. That's what none is. 11% on Azure. 11% on AIX. 62% running VMware.
There's 11% that's not going to 12.
Wait, I have a slide later, okay? Every one of our AIX customers are already in the process of migrating to to Linux. So some have done it, some have done it partially. Like we have an application partner that has about 100 of their hosted customers on AIX. So they've started moving their customers one at a time to Linux from AIX. So by this time, again, next year, nobody should be on AIX anymore. Anybody here on AIX? Oh, a couple of guys. Are you moving? Like, are you in the process of moving? Okay, good. So you need ProTop. You absolutely need ProTop to help you in that migration. Oh, sorry, I said it wasn't a sales presentation. I apologize. Oops, sorry.
Think about who you have in the room.
I'm going to make a note of that, Paul.
Who do I have in the room?
Hey, well, it doesn't make a difference anymore.
No, it wouldn't have made a difference before either. When was the last time I kept my tongue in my mouth here? Yeah, so who's running VMware? I just want to see if the numbers are about the same. Oh, so less here. So we got a sort of kind of here. Azure? AWS? Well, what are you running on then? Bare metal or Prox? Oh, we got Proxmox coming in. I'm hearing a lot now that they changed the pricing model. Did you change because of the pricing model, or you were always on Proxmox?
Running for over 20 years now.
Ah, that's amazing. Yeah, I'm hearing a lot more interest in Proxmox because Broadcom is screwing around with the pricing models for ESXi, and so there's a lot more interest. Anybody else on Proxmox? Sort of, kind of. I would love to get some data off you. If you want to come see me after, I'd love to get ProTop in there just to see what the data looks like in terms of Proxmox. Yeah.
Well, private cloud. I mean, I'm in private cloud.
So even in private cloud, they're running VMware, right? They'll be running VMware almost 100% of the time, really. So we do have customers. That's not even private cloud. You know, they're in a data center, a private data center, and they've got a rack of theirs with their hardware in it. But I call that's for me. That's like it's your hardware. You just put it in somebody else's closet, really, right? So, yeah.
Where is Hyper-V in that list?
I don't know. I'm sorry.
Is that unknown?
Is it Hyper-V? Anybody? Anyone? You really?
Not me.
Okay, Jesus. I don't think I mean, maybe some of the unknowns are Hyper-V. I don't know any of our customers who are running Hyper-V. Do you have it? When was the last time you saw Hyper-V somewhere?
If it was virtualized, it was VMware. 100%.
Yeah. And Proxmox, you're the first one. I haven't heard yet of a customer or like an OpenEdge environment running Proxmox. But again, I'm hearing a lot more buzz because of the cost changes to ESXi. So, but seriously, anyone Hyper-V? No, you don't want to admit it. Is that? Sorry?
We've got one customer on it.
One customer on Hyper-V?
Yeah, Linux on Hyper-V.
Yeah, so.
I've got one on my laptop like that as well, but
Oh, that doesn't count. Production environments. I had Hyper-V running on a laptop once too, and then I decided it was shit, and I threw it away, and I bought VMware instead. Just so you know, ProTop, we run everything in AWS Cloud. We're fully containerized, Docker, Kubernetes, everything. But we run VMware servers internally, which we use for testing, and we use them as jump boxes. So instead of everybody having to install every frickin' VPN in the world, because you all use different VPN software, we install the VPN software on a jump box on an ESXi server, and people go into the jump box, and then from the jump box, they go to the customer sites. All right. Operating systems. Red Hat is 50%, right? And then all the AIX guys are all going to Red Hat. I think there's one or two that are looking at Ubuntu, but essentially everyone's going to Red Hat and AIX. 17% Windows. And then the other ones, like I said, CentOS is going to go away too, right? It's not supported anymore, so that'll be gone. And then the other ones are just little tiny ones here and there. So again, who's Red Hat here? Red Hat Windows in production. Okay, that's pretty good. So about this good. So again, mostly we're seeing Red Hat. And again, all of the HPUX, AIX people who are moving to something, they're all moving to Red Hat. They're, like I said, maybe one is going to Ubuntu, but really everyone's going to Red Hat for this. All right. how many cores per server do people have? So half of our customers, half of the servers, I should say, that I have data for have 4 cores or less on the virtual machine. So then you could argue afterwards if that's a real core or whatever with hyper-threading and whatever. But as far as the virtual machine is concerned, most of them have 4 cores or less. A bunch of them have 8 cores also. And then you can see afterwards it trends down pretty quickly here afterwards when you start going to more cores, right? And there's always the NUMA issue, and I'll talk about it a bit later. But if you're not aware of the NUMA issue, talk to me, talk to Mike in the back or one of the guys, right? If you look at your server and it says you have, I don't know, 32 cores or 24 cores, you might have a problem that you don't even know about, right? And that's being a NUMA issue. So if you don't know what I'm talking about and you have a large environment with a lot of cores, again, grab one of the guys, Mike, me, Tom. Are you doing a NUMA talk?
And not Numa, but it's just part of my common problems.
There you go. So come and see Mike's talk tomorrow on common problems. And NUMA has become a more common problem as the servers you buy become bigger and bigger. All right? But I thought that was pretty cool. 4 cores and 8 cores seem to be the big ones. The 0 and the 1s might be, so the 0 is just for fun. Those are dev servers with less than a CPU in them. So they show up as fractional CPUs in there. What else do I got here? The largest single table is 4 terabytes. And the largest single database is 20 terabytes, and it's not the database with the 4 terabyte table, right? So like when you hear me give a talk and I'm advocating on all variable length extents, and then Mike stands up and says it's not for everybody, this is the not everybody he's referring to here, all right? So when we say you should use all variable length extents, you know, it's a general rule, but if you're up in these kinds of multi-terabyte databases, then those rules don't necessarily apply to you. And you have to remember, like, you know, 20 years ago, a large database was a gigabyte, you know, and then it was 10 gigabytes. Oh my God, 10 gigabytes, right? And now, like, you could put a 20 gigabyte database on your phone. I mean, like, you could run a SQLite database that's 20 gigabytes on your phone. So 20 gigabytes today is just a database. It's nothing. You could back it up in a few minutes. You can restore it in a few minutes. Like, you can do whatever you want with 20 gigabytes today. So does anybody here have terabyte database? So we do have a few terabytes. So for you guys, I'm not talking about variable length extents, but if you heard me talk about that, it would not necessarily apply to you for all your storage areas. All right. The largest single customer site, so that's one production environment, but multiple databases, was 75 terabytes, and actually times 2 because they have a replication target environment too. So, that's a backup, right? That's a nightly backup, 75 terabytes every night. Let's go, baby. All right. What else do we got? Most concurrent users, 15,000, but that's cheating because it's through app servers, so they're indirect connections. But the most concurrent database connections I've seen is 4,000 concurrent database connections on one single database. And the largest -B I found was 100 gigs of RAM, which is a -B of 12 million times an 8K block size. So 100 gigs of RAM. Most people don't have 100 gigs of RAM in their server. They got a -B of 100 gigs. And the largest -N was 16,000 that I saw here, which was probably on that 4,000 concurrent DB user. So, and then when you have numbers like this, you have to remember, like, the amount of shared memory isn't just your -B, right? Your shared memory could be your table range size and your index range size. So now you're like, I have 1,000 tables and 1,000 indexes. That's 2,000 times 16,000, right? Times whatever the size of each thing. That's actually starting to consume real memory here when you have those kinds of numbers. So you got to take those into account, right? And then, yeah.
Does that actually make a difference? 100 gigabytes of shared memory for the buffer pool? Because your working set of data is at most 1 gigabyte, 2 gigabyte?
It depends.
It depends.
It depends.
Yeah, it depends.
More than 1 GB data?
I've seen customers that every 10 minutes would export out full tables because they didn't know about Pro 2 when they were ETLing them. And
Oh,
so,
they're doing statistics on the data.
yeah, so
Oh,
they're so people are just flushing these big massive tables into the buffer pool so they can just get them out on disk, and they do it every 10 minutes.
They
Yeah.
should use private buffers for that.
They can do what?
They should use private buffers for that.
Right. They weren't, but yes.
Yeah, and I'm not saying that this minus B of 12 million was intelligent, right? I mean, I just went into my dash. I have all the data, and I said, what's the largest minus B value? And it was here, and I wrote it down. I didn't go and ask the customer, why do you need a minus B of 100 gigs? So
The other thing you got to be concerned about is you have a machine that has 100 gigabytes of memory, which is fine, right? In order to get memory of that size, most likely you're going to be getting into NUMA as well, because you can't get.
yeah, you can get 256 gigs on one node.
Right, so you got to be careful, because as soon as you get a dash big B that expands across that
you're
that NUMA
screwed.
boundary, now you may be isolating yourself from NUMA as much as you can. Get memory 1 byte over, and boom, you are now completely NUMA.
So I don't know if anybody has seen, I did a benchmarking talk last year, if anybody saw it, and for this NUMA issue, and go see Mike's talk tomorrow, he'll go into it, but I basically ran all my processes. There's a benchmark in ProTop which just reads as hard as it can in the database. And so I just kept adding processes, but I was using a command to force them on one NUMA node, right? And I was pushing, the max I could get was 4 million reads per second, right, out of the database. And then after that, if I added, it didn't help at all, right? So that was my super benchmark, 4 million reads per second out of the database. And then I took one process, and I started it on another NUMA node, and my global reads per second on the database went from 4 million to 3 million. And then when I added a second process outside the NUMA node, I went from 3 million to 2 million. So when we talk about this NUMA problem, you only need one process running on a different NUMA node to kill your performance. So it's not a linear thing, it's an exponential thing. You fall off the cliff as soon as one process is running on a different NUMA node. So it's actually serious. It's not a little thing. And not only is it serious, it's not something for big companies anymore. You all have the potential probably today to face the NUMA issue because of misconfiguration. And I hope Mike is going to talk about that tomorrow, or you can come see us during the expo and we'll dig into it in more detail. All right, where am I? Okay, funny, we're talking about all these large databases, but there's a lot of really tiny databases out there, because a lot of applications have the one database, and then they've got 3 or 4 little tiny databases next to them, right? So the mean database size was 183 megabytes. Now, I didn't sample all 10,000 for this one. I only pulled this out of one server that had about 1,000 databases, and the median size was 23 megabytes, and the smallest was 2 megabytes on this particular server. So you can see we talk about all these monster ones, but everyone's always running little tiny databases too. This database has the countries in it, and this database has the currencies in it, and this has static data, and this is the help database, and so on and so forth. And then over here is the database, that has 50 gigs in it. And the longest uptime I saw at that point is 375 days, though I have had customers who've been up for the longest I've ever seen in my life is 3 years of uptime. And the reason why I remember that is because they had to do maintenance and this server had not been rebooted in 3 years, a physical server. It was bare metal. And so there was a fear, we haven't turned this server off in 3 years. What happens when I turn it off, right? I mean, you haven't turned something off in 3 years. There is an actual real possibility that it doesn't power on after you power it off, which is why we tell you should cycle your machines at least every 6 months, every years, just to see if they cycle. But is anybody here up for, continuously up for over a year? Nobody? 6 months? Maybe? Yeah. So we talk about 5 nines and all of this, but please do cycle the machines. Cycle your servers and your databases and your PaaS-OE and your app servers. And the other thing we're seeing now more and more often is people, and I love this, right? And if you guys could do this, it would be amazing. People are running 3 months on their primary, 3 months on their secondary, 3 months on their primary, 3 months on their secondary. So it forces them as a corporation to keep their DR plans and everything up to date because they run 3 months, 3 months, 3 months. So they know every 3 months, like clockwork, they're switching production over to the other data set, right? And so they can go to the C-suite and say, we are confident that if we have an emergency, we can switch. Why? Because we do it every 3 months. We know exactly how to do it. The process has been tested, retested, redone. If you guys could work that in, that is, for me, the holy grail of high availability. Switch every 3 months back and forth, right? And that's a little off topic from here, but there you go. And about half of our databases have at least been up for a couple of weeks here. All right. So this gets interesting now. We're talking about logical reads and logical writes. People always ask this question about hit ratios and everything. So you can see here across all, this is just the North American portal because it was too hard to get all the data. We have about 23 ProTop portals across the world. So getting all that data from them was challenging. So this is from one representative portal in North America, about 1,000 databases. You can see the mean logical reads per second is about 60,000 reads per second. That's about the mean logical reads per second that we have across all our databases, or these 1,000 databases or so. And the maximum logical reads, and I know which client this is somewhere in that 4 million. And then you can see here, like 4 million is here. So peaking up to 6 or 7 million here reads per second across. And then you can see this is at night. This is 10 p.m., 11 p.m., and then going into the night. So you can see batch processing, right? So across our American customers, we can see that batch processing really occurs at night, and backups, of course, are occurring at night. So we have a higher average throughput of logical reads or maximum logical reads at night than we do during like regular business day here. And then when you add them all up, I think that's the next slide. Yeah. So when you add them all up, what do you get here? You get like 100 million. That's 100 million there. So 100 million and up logical reads per second across about 1,000 databases or so. So that's how much activity is occurring. And we're grabbing all those statistics every minute and then uploading them to our web portal. For operating system reads, so this is interesting because this is your buffer hit ratio, right? So we're doing you see here about 2 million operating system reads per second. And then when I look at that data, I have it later. Oh, here's the hit ratio. Sorry, what was the previous one? So yeah, so when I take the hit ratio, which is actually pretty good, you can see that for most, like the average across all our databases is around 99% and higher buffer hits, right? And I always stress to people, you want 99 point something percent buffer hits. You don't want 98 or 97. We have this misconception that 95 is very good, right? But if you think about it, 95% buffer hit means 5 out of 100 read requests go to disk. Make sense? 99% is 1 out of 100. So 95% buffer hits is actually 5 times worse than 99% buffer hits. It's not 4% worse. It's 500% worse. You're going to disk every 20 instead of every 100 reads. So that's why we tell you to strive for 99% buffer hits. And you were talking about working sets. You're absolutely right. You want that working set to fit in the -B, and that's what you're striving for. And then what you're trying to do with tools like ProTop is identify the ones that are going outside of the working set, right? The bad code that's going outside of the working set, and then you want to correct that bad code, and then that makes your working set smaller. And the other advantage of identifying that code, and really it's one of the strengths of ProTop, it shows you which tables, which indexes are being hit, and it tells you which code is hitting those tables and indexes, and then you can go back and fix them. And if you have a large environment with 100 production databases, if you curb your logical reads by 20 or 30%, you're essentially curbing your CPU requirements by 20 or 30%, which translate into actual real cost savings in your infrastructure, right? You can use less CPU, less memory, less disk I/O to support your environment by making some, I hope, relatively simple code changes. So it's not just a question of improving the performance of the application. If you have a wide enough production environment with a lot of servers in it, you're actually saving a very significant amount of money by making these code improvements.
Increasing your disk I/O, you're probably increasing your CPU load, making the process go faster.
As you're increasing your disk I/O,
As you're decreasing the disk I/O,
as you're decreasing disk I/O,
increasing your CPU utilization because the process goes faster.
yeah, definitely. But it's a trade-off, right? If you don't have enough if you have enough memory, then yes, you decrease disk I/O at the expense of RAM, but you don't decrease CPU because CPU is doing just as much reads. But if you fix the query, then of course you're using less CPU because you're reading less records and less indexes, which requires a smaller minus B, which will in turn lead to less disk I/O. So it really it cascades into all of the infrastructure components when you fix a bad query, right? And we're working right now with an application partner. They host all of their customers, so they pay for all of this infrastructure, and they've been on a tear of fixing their code. They're migrating from AIX to Linux, and they're realizing as they repair the code, if they make one small improvement, they multiply that savings cost by 100 production environments. That starts to be real money that you're saving by quickly identifying and correcting code that's doing, a large amount of reads or writes or whatever the case may be. So there's definitely, tuning from the database perspective. We'll come in and tune it, but in reality, you can only hide bad code to a certain point. At some point, you're going to bottleneck on CPU because the CPU is reading the bad records out of the database, essentially. All right. I'm doing okay on time. Good. So let's switch to logical writes. So the mean logical writes per second, interesting, just like about 200 writes per second. And that just reinforces that most of our OpenEdge applications, they're OLTP type applications. So they do a lot more reads than they do writes in the database. And if I look at even the max, you see that max is really trending around 50,000 logical writes per second, right? Remember, my max logical reads was 4 million and up. My max logical writes is 50,000. All right. And when I compare them, and the sum about 500,000. So we were at 100 million sum of logical reads, and we're at 500,000 sum of logical writes, roughly, across 1,000 odd databases here. So what does that compare?
Is that a 2-to-1 ratio?
No, much more. It's 120 million to 500,000. Yeah. So the ratio is 240 logical reads per logical write, or 99.6% of I/O is a logical read, and 0.4% is a logical write to the database. Right? So really all of your applications across the board, they just read, right? Read. Okay. Cool. Any questions so far? I'm zipping through these. It's good.
So one comment, like when I was back in progress and people would be asking about Pro 2 and CDC, I would have the same stats. That'd be, the ratio is somewhere between 300 and 500 for this,
Yeah.
you know, the stuff we're managing. And I'm like, Pro 2 and CDC, you know, these things that are tracking updates, all they're going to do is double your update. So you're going to go from a read ratio of 300 to 1 to 150 to 1. You're not going to notice it because it doesn't affect reads at all.
No, exactly. So we're just saying here, obviously you have to tune your database so that it writes efficiently, and you have to tune your infrastructure, your hardware, so that you're writing efficiently. But if everything is tuned properly and you use Pro 2 and it doubles your database writes, no one's going to notice, right? Unless the hardware is not tuned properly.
It's not database writes, it's record writes.
Record writes. So definitely there again. It's also it's like people used to be afraid to implement AI after imaging because they thought it was going to affect performance. And yes, if you have a poorly tuned system and you screw up how you turn on AI and how it's done, yes, it could affect performance, absolutely. But if you put in a minimum amount of effort, read a couple of documents, download a couple of presentations from the old PUGs about how to implement AI. AI will not affect your performance in a meaningful way. And what do I say meaningful way? Because you implement AI and your performance drops, your write performance drops by 1%. So 0.4% of your DBIO has suffered a 1% drop in performance. That's a total cost of half a millisecond or something, right? No one is going to notice that. So you need to separate some mathematical abstract. 3%, performance loss to 1 millisecond, right? Like you need to be logical here. So, all right. How fast can you pull data off the disk? So there's two metrics that ProTop monitors that are different from what Zabbix or Nagios or whatever is monitoring, right? So we monitor how fast can you pull one of those 4K or 8K blocks off the disk, right? Random reads. How fast can I pull a random block off the disk? And the second thing is I want to simulate how fast I can write to the AI and the BI files. So how fast can I do an unbuffered write to disk? Because my writes to the AI and the BI, they have to go right through the disk. They're unbuffered, or rather, they're right through the buffer. That's the more proper term. But regardless, they don't get buffered by the operating system and then get written at some other point in time. And your regular disk monitoring tools don't monitor for that. So we monitor for that. So what's acceptable? If you're a single digit millisecond random access time, you're doing okay. That's a normal SAN, a normal disk. If you're running flash or SSD on a SAN, guess what? It's the same freaking thing, okay? Because if I give you a Ferrari, but then I put the Ferrari in another country, you're not any faster, right? It's way over there. You're not getting there any faster. So flash in a SAN is not the same as flash in the box where the server is running. So we have customers who have flash on the box, and here you're actually talking about like 50 microseconds to read the data versus 1 or 2 milliseconds when you're going on the SAN. And the same thing happens on write speed. On a normal SAN, you should be able to write unbuffered at least 10 megabytes per second, at least 10 megabytes. I want to see more, 20 and more, but at least 10. If you can download ProTop RT, it's free. It has this test. You run the test in ProTop RT, it's free. If you see 3 or 4 megabytes per second on the sync IO metric, there's a problem there, right? You've got a disk write problem. And again, your SAN administrator is not going to see that because he's not monitoring for those unbuffered writes from the server across the Brocade network to the SAN and then eventually to disk. All right. So watch out for that. An AWS GP3 drive should give you 30 megabytes per second. If you just go into AWS, you say click, I want a GP3, 100 gigabytes, click, and you do the test on it in Linux, you should get about 30 megabytes per second. All right? So try this test at home. Again, download ProTop RT from protop.com. It's free. The test will run automatically, and just pull the data out of there and see. Good. So here, I got some examples here, right? Because again, we always have some fun stuff. So here's Azure, 2 customers in Azure. They're in the same data center, the same Azure data center. This guy configured his disks here, and he's getting random reads of under a millisecond, and he's getting 52 megabytes per second in terms of how fast he can write unbuffered to disk. Here's another client here. Whoa. What are you doing, you? What are you doing? Here. He's not letting me go down. There it is. So this guy over here, if you can see, there we go, zoom there. This guy's getting half the speed for random reads and 1/10 the speed for unbuffered writes. What's the difference? Disk configuration, right? So this guy is using whatever they're called. This guy's using the premium discs, and this guy I think is using the ultra discs or something. And between you and me, I have limited experience on Azure versus my experience on AWS. I just find there's a lot more buttons you can tweak and turn on AWS than you can Azure. It's more like, I want this, and I want this, and I want this. Whereas AWS, I find I want 500 megabytes per second, and I want this much disk space. I want 426 terabytes. That's what I want, and you can get that. Whereas in Azure, it's not quite like that. So, is there anybody on AWS? No? No one on AWS? Okay. Anyone on Azure? Did I ask before? A few? Yeah, so if you go play, you'll see the difference, right? It's just a little bit harder to configure. And then I just looked at a couple of customers here on AWS. So same kind of idea here, just a well-configured system here with a GP3 disk, about 1/3 of a millisecond random access, and 33 megabytes per second on a GP3 disk. This guy, I don't know what the hell he's got configured here. Like, this guy had to work hard to get this bad performance on AWS, right? And he's getting half a millisecond random read and only 8 megabytes per second. I honestly, I don't know how you could get 8 megabytes per second sync IO write times on AWS. Maybe he configured those magnetic disks or something that I don't even know how he could have done that. So, but very crappy. So again, go test this at home. And then we're talking about NUMA nodes, okay? So we talked about NUMA nodes a lot. I got a couple of slides here, and then we're done for the day. But like, here is an example where frickin' Azure is lying. They're lying, okay? He tells me I have 32 Xeon Platinums on an 8272 CL, and he tells me I have 1 NUMA node. Well, guess what? An 8272 CL only has 26 freaking cores, so I cannot be on 1 NUMA node. So Azure is lying to me. How can I be on 32 cores when the actual physical chip only has 26 cores? But if you go and you look in the NUMA info, it says number of NUMA nodes 1. So Azure is lying to you here. So watch out for that. And we asked Azure, you know what we got as an answer? Nothing. Crickets. Oh, I don't know. I'll have to check with that. And we never got an answer from Azure, right? So this client is suffering performance issues. We keep telling him to drop to less CPUs. Told him drop to less than 26. I'm like, you're not using all these CPUs. You're suffering. Drop to less than 26 CPUs. Oh, no, Azure says it's fine. I'm like, okay. Azure says it's fine. I say it's not fine, but Azure says it's fine. Because you always trust Microsoft. They always tell you the truth, right? All right? But if I see this, I know the information is incorrect. All right? It's impossible. All right? And in ProTop, we have this metric called BOGO MIPS. And again, if you run the free version of ProTop RT, you'll get this data for free in the real-time version. You just won't have it graphed like this. But if I see a lot of zigzagging in this BOGO MIPS number all the time, I know either the server is overtaxed or I'm potentially facing a NUMA issue. What I really want to see is kind of like this. You see how I kind of have this nice plateau with some dip down? That's kind of normal of what I see on a virtualized server. When I see like this, always jagged up and down, right? And it just doesn't seem right. And then when I look at the CPU graph for these same servers, this server that's jagged up and down is sitting at always between 85 and 100% idle. So it's not only jagged. I know it's not an issue with a lot of CPU usage because I'm 80 to 100% idle all of the time. So how come I'm jagged like that? Could be a NUMA issue. Could be. But it's at least for you now, you can go look and you can go check and say, oh, this data doesn't make sense. I need to go check. Whereas over here, this customer, now you can see I've got a lot more CPU usage here, which kind of tracks with my jagged up and downs over here. So I'm like, okay, that makes sense. When I my BOGO MIPS kind of goes down, it's when my CPU usage goes up. I can kind of track the two together. Okay, that makes sense to me, right? So these are the kinds of things you need to watch out for when you're going back into your own environments. I think I'm done. Yes. With 10 minutes to spare. Questions, anyone? Questions? Who tried Beat Saber already? You got to come try the Beat Saber, the game at our booth. So we have good prize. First prize is an Apple Watch. Second prize is a Beats Bluetooth speaker. So come by the booth, ask questions, try Beat Saber, try to beat the high score, and win some prizes. Thank you very much.